All right, so for this one, this is a source conversion problem. It's not nodal. It says source transformation, just another word for source conversion. Determine the voltage drop VAB, so from right here to right here across the 10 ohm resistor and the IR through the resistor. Now, note that this is worth labeling the node because this calls this node A, but really all of this right there and all of this right here is B. Here's A, here's B. I have two other nodes that are here, we'll call them C and D. And so the two things that we can source transform, we can either source transform a voltage source in series or a current source in parallel. So while it is possible to transform this box in green right here, it is possible to transform that. My rule of thumb that I said is don't transform the element that you're looking for. And since I'm looking for this stuff between A and B, I'm not going to transform those. Because if I did transform it, it would put them inside of the circuit up in here or down in here, which doesn't help me necessarily. It is a way to do it. It's not how I would do it. So if you wanted to see that explanation, we could work that one afterward. But what I'm going to transform is what I'm boxing in orange here, which is the voltage source and the two elements that are in series with it. I say two elements in series because C is exclusively shared between the 24 ohm inductor, which I could label with a J, and the 12 ohm resistor. So if I was to put that into a box, I could draw it once before I even transform it all. But here is my Z, 12 plus J 24. Here's negative J16 capacitor. And then here's my 500 milliamp angle 0. And there's the 10 ohm resistor. So anytime that I'm doing source transformation, I'm doing the Z and I'm using V equals IZ. I'm solving for an I, which is V over Z, and it's the S, right? The source, the voltage source, the current source, and the Z next to the source. Well, the Z next to the source in this case is 12 plus J24. That's the one in series with the voltage source. And whenever I do that, I get, make sure I got it right, 449 milliamps, angle negative 158.2 degrees. So now if I'm redrawing the whole circuit, right, what was in orange right here, and it's like I cut it off here and I cut it off here. It's like I unplugged it from the circuit, I grabbed another equivalent element and I plugged it back in. From the perspective of everything to the right of the X's, it doesn't know what's inside the circuit. So I plugged back in, and I'll draw this in blue. Here's my current going up, and I take that same Z, 12 plus J 24, the same Z in a box, I leave inside of here. There's the capacitor, there's the current source, and there's the resistor. This is 449 angle negative 158.2, negative 16J, and that's 500 angle 0. So now if I needed to find the voltage across this, I could put all of them together because now all of this is A and all of this is B. So if I needed VAB, I can now just take the totals, right? And I can say that I'm looking for V total by combining the I totals and the Z totals, right? VAB will be all of them. And so the I total, you know what I realized this number is not right. The 449 is the I total. 449 milliamps, angle negative 158.2. That, woo! Nope. I'll just exit out. That's the I total. This one came out to 186, angle negative 63.4 milliamps. If you plugged in 5 divided by 12 plus J 24, you would have gotten 186. And so my I total in this case would be 500 minus 186 angle negative 63.4. And that's when I get 449 angle negative 158.2. All right. And then my Z total, that I would put all of these together, this would be I total, Z total would be 1 over 12 plus J 24 plus 1 over negative J 16 plus 1 over 10 ohms. All of those together come out to 8.32 angle negative 14.04 ohms. So V total would be 3.75 volts, angle negative 172.2 degrees. And that V total is VAB. And then whenever I do I'm looking for the current through that 10 ohm resistor. Well, that VAB is the same thing. VAB is equal to I through the 10 ohm resistor as the resistance of the 10 ohm resistor. That is the voltage across the 10 ohm resistor, because this is going back to circuit analysis of just being able to look between what is between A and B. This is the faster way to do it. If you go to the Jeopardy solutions, they also have a more complicated way to do it with current divider rule. If you wanted to practice that, just to practice current divider rule, you could also do that. 172.2 V equals IR in this case, because it is IZ, but the Z is just a resistor whenever we're looking at the 10 ohm resistor. So if V equals IZ, then I equals V over Z, and I have 10, that's like saying angle 0. And so the I going through the 10 ohm resistor, which is what they called IR, is equal to 370, and this is rounding error now, 375 milliamps, angle negative 172.2.